This lesson discusses the binomial distribution, also standard deviation and z-scores. Number 1, a certain company's IT department has found that 18% of all visitors to the company's website arrive there in error. They are actually looking for another website. If this percentage is correct, what is the probability that in a random sample of 7 visitors to the website, exactly 2 of them arrive in error? So that's a combination because it doesn't matter what order that they arrive in error, just somewhere 2 of those 7 visitors are going to be there by mistake. So if 18% of them arrived by mistake out of 100% of people, so 100% minus 18% is 82%. 82% got there correctly. So the probability of the whole thing happening, you got to take the probability of how many events are possible, so that was 7 combination 2, and then multiply that by the probability of what happened, which is 82% of the time, 5 of them got there correct, and then 18% of them got there incorrectly, so 2 of them. So again, on the calculator, go to math, and then go over, so math's on the 3rd row down, and then go over to the menu that says probability, and go down to the 3rd choice, combination. And again, you got to put the number in first, which I forgot to do again, so I'm going to put the 7 in. So 7, math. Go over to probability, down to choice 3, combination. So 7 choose 2 is 21, and then times 0.82 to the 5th. So times, let's see, 0.82 caret 5. And then I need to multiply that by 0.18 to the 2nd. And we get our answer to the nearest thousands, or 3 decimal places, 0.252. Next one. On the package for a certain brand of spinach seeds, there is a guarantee that if the printed instructions are followed, 63% of the planted seeds will germinate. A random sample of 9 seeds is chosen. If these seeds are planted according to the instructions, find the probability that more than 7 of them germinate. So more than 7 of them. So that would be 8 or 9. And again, 63% of them will germinate, which means out of 100%, 100 minus 63, 37% of them won't germinate. So again, we want to know out of 9 seeds, more than 7, so that could be 8 seeds or it could be 9 seeds. So we need to add those probabilities together. The probability that 8 of them germinate and the probability that 9 of them germinate. And again, 0.63 of them will germinate, we're saying, 8 times, and then 1 of them won't. And then if it's 9 of them are successful, then 0 of them are not successful. And then you add together those probabilities, which is 0.098. On the next one, it says, the ages and years of the 5 doctors at a local clinic are the following: 43, 55, 54, 40, 43. Assuming these ages constitute an entire population, find the standard deviation of the population. Round your answer to the 2 decimal places. All right. Well, super quick answer, then we'll go into the longer answer, is take your calculator. You go to the word stat on the 2nd row, and then under the menu that says edit, you're going to go, if there's anything in there, go up to the top, hit clear, go down. Anyway, I'm going to put those numbers under list 1. So 43, 55, 54, 40, 43. All right, so I put them all in list 1. So I go back to the word stat now on the 2nd row, go over one menu to calculate, and it's the very first choice, one variable statistics. So I want list 1 to calculate. And so calculate. So you're looking for the sigma symbol, the 0, the O looking thing with a little wave on top, that's sigma. So sigma x is 6.22896. So that is the standard deviation of it. And that's what they wanted to have, standard deviation. So, okay, so the longer answer to how you do that. Standard deviation, or sigma, of a population is a measure of the spread of the measurements of the population about their mean. And they give a fancy word to it, just like they do for standard deviation, is the Greek letter sigma. They use the Greek letter mu which is like a U with the line to the left. So mu about their mean, or again, mu. So if we found mu, or if we found the mean of those numbers, add them all up, divide by 5, it's 47. That's step 1, defining standard deviation. Step 2 is you compute the average of their squared deviation from the mean, and then you square it. So our mean was 47. You got to take 47 minus each and every one of those 5 numbers that were there. So that is, let's see. So we did the average of their standard deviation from the mean. So how far it is from the mean. So we subtracted the numbers in each and every one of from the mean, and then you square them, and then add them all together and divide by how many there are, because we're doing the average of it, and it's 38.5, 38.8. And the last step is you take the square root of that number. So the square root of it is 6.23. So again, from the top, mathematically how you do it, first thing you have to do is find the mean. Then you take the number that's the mean, you subtract it from all the numbers that you had there, and after you subtract them, you square all of them, add them together, and then divide, because you're taking the average, divide by how many numbers there were there, which were 5. And then last of all, after you get that number, you take the square root of it on step 3, which gives you 6.23. All right. Next one. The annual rainfall in a certain region is modeled using the normal distribution shown below. The mean of the distribution is 36.5, and the standard deviation is 5.2. So if the mean is 36.5, right here, the mean in the middle of this normal distribution or normalized curve goes right here in the middle. So that's where the mean is, 36.5. It's got a standard deviation of 5.2. So you count out 5.2 to the right, and you subtract 5.2 going to the left. In the figure, V is a number along the axis and is under the highest part of the curve. And again, the highest part of the curve is the mean. So that's V. And U and W are numbers along the axis that are the same distance away from V. Use the empirical rule to choose the best value for the percentage of the area under the curve that is shaded, and find the values of U, V, and W. Okay, the empirical rule says that 68% of the area under the curve lies within 1 standard deviation of the mean, 95% of the area under the curve lies within 2 standard deviations, and 99.7% of the area under the curve lies within 3 standard deviations of the mean. All right, so going out 1 standard deviation each way, so adding 5.2 and subtracting 5.2 from the mean, takes us 1 standard deviation away both ways to 31.3 and 41.7. Again, add and subtract 5.2, which takes you to 26.1 and 46.9. Do it again. It takes you out to about where we're at then, 20.9 and 52.1. So we went out 1, 2, 3 standard deviations to do that. And that gives us 20.9 and 52.1. And again, V is the mean, which is 36.5. And then just for fun, because everybody does like this, everybody when they think of standard deviation, they think about IQ. The average IQ is 100, and the standard deviation for it's 15. So within 1 standard deviation is 68% of the population. So 68% of the population is between 85 and 115. Go out 2 standard deviations to 95% of the population. That takes you between the IQ of 70 and 130. And then outside of that, or 99.7, the IQs go from 55 to 145. So if somebody says they have a 200 IQ, they're just making numbers up, and they don't even know what IQ is. It stops around 145. I mean, I guess you could go a little bit higher than that, but overall, it's over at 145. All right. Number 5. At one university, the mean distance commuted to campus by students is 18 miles, with a standard deviation of 4.1 miles. Suppose that the commute distance are normally distributed. Complete the following statements. Okay, so they said 18 is the mean, so I put it here in the middle of the hump, and the standard deviation is 4.1, so I added and subtracted 4.1 going left and right. So if you add 4.1 and subtract 4.1, it takes you to 22.1 and 13.9. Doing it again. add and subtract 4.1 or one more standard deviation out, takes you to 26.2 and 9.8. Do it again. You go to 30.3 and 5.7, which takes you out to 99.7% of the clientele. So they want to know if the students are between 9.8 and 26.2, this question here, that means they're at 95%. This is 68, 95, 99.7 by the empirical rule. So this one was 95. And then if we want to go to 6 to 8, which is the first standard deviation out, it's between 13.9 and 22.1. On the next question, it says the standard normal, which means if they standardize the whole normal, that means the mean or the average of the data is 0, and the standard deviation of it is 1. They like to standardize test. So that's what it means. The standard normal is graph below. Shade the region under the standard normal to the left of the z-score being -2. So now you're thinking, what the heck is a z-score? So let's go down and discuss what a z-score is. A z-score, also called the standard score, gives you an idea of how far from the mean a data point is, or how many standard deviations below or above the mean a raw score is. SD is standard deviation. Or again, they use the sigma symbol. I guess I could have done that. All right, so if they're saying the z-score is -2, that means we're -2 standard deviations from the mean. So we're going over 1, 2. So -2, I drew a line for fun and then shaded to the left because they wanted it to the left. All right, and then they'd like to know what is the area of that curve to the left of it. All right, so they said you could use your calculator on the program, or they have a chart you could look it up on, or we could use our calculator. Let me show you how to use your calculator for it. What you want to do is go to second vars, which is the third row down, VARS. Go to second vars. You want choice number 2, the normal CDF. And then from that, our lower bound, all right, so looking at the picture here, the lower bound to the left, it goes to -infinity. So for -infinity, we're going to enter -10 to the 99th. For positive infinity, what you do on the calculator is enter 10 to the positive 99th. So 10 caret 99. So the lower bound is -infinity on this problem. The upper bound is right here. So, all right. So the lower bound is -10, caret 99. The upper bound is -2, because that was the z-score, -2. And then mu, or the mean, was 0. Sigma, or the standard deviation, was 1. So if you have an older calculator, it doesn't let you do this, enter all these numbers. So you're just going to have to enter it in it with commas in between them. You're going to have to enter -10 to the 99th, comma, -2, comma, 0, 1. So on the older calculators, let me write that down for you. Inside the parentheses, it's no problem owning an older calculator, but just unfortunately when you get to higher math problems like this, having the newer version of it makes it just really nice. So you got the lower, the upper, and then you're going to enter the average, or mu, and then you're going to enter the standard deviation, or sigma, on the older calculator. So anyway, the new ones just paste it in there for you. And then if you hit enter, it gives us our answer of 0.028. Oh, 0.002, I guess it's a 3. Well, what do they want it to? 4 places? Oh, 4 places. So yeah, that's an 8. So 0.0228. All right. Next one. It says, use the table in the ALEKS calculator to complete the following. Give the answer to 4 decimal places. So this one would like to find the area under the standard curve to the right of the z-score being -1.06. So if we're going to the right of it, so all right, so there's mu, which is 0. So -1.06 is over to the left somewhere from 0, and they want it to the right of it. So they'd like to know the area of all of this. So we're going from the lower bound being -1.06 to the upper bound being 10 to the positive, 10 to the 99th, or positive infinity. So on the calculator, under normal CDF, you're going to enter -1.06, then the upper bound 10 to the 99th, and then the average mu, which is 0, and then the standard deviation of 1. All right. So again, going to second vars, choice number 2, normal CDF, I have got, let's see, negative 1.06, and then 10 to the 99th, and then the average is still 0 and the standard deviation is 1. So I get that answer to the nearest 4 places of 0.8554. Okay, next one. It wants to find the area under the curve between the z-score of 1.28 and 2.74. All right, so again, here's our normal curve. So 1.28 would be about here, and then 2.74 would be over here somewhere. So the lower bound is 1.28. The upper bound is 2.74. So lower, upper, the mean is 0, the standard deviation is 1. Put them all under normal CDF and you're going to get that answer. So again, second vars, choice 2, normal CDF. So 1.28, 2.74, 0 and 1 still. All right, so that gives me the answer I wrote there, 0.0972. Number 8, the last one here. Then the questions repeat on your homework. It says a certain manufacturer makes 400-watt light bulbs. Assume that these light bulbs have lifetimes that are normally distributed with a mean life of 435 hours. So I put the mean here on the middle of the curve, 435. And the standard deviation is 60. So then I counted out 60 each way, adding and subtracting 60. Took me to 495, 375, go out another 60, 555, 315. All right, it says use this table or your Alex calculator to find the percentage of light bulbs with lifetimes longer than 501 hours. For your intermediate computations, use 4 or more decimal places. Give your final answer to 2 decimal places. For example, 92.23%. All right, so they gave us a raw number, not a z-score. So what we have to do, I should highlight this for you guys. You're going to want to write this formula down somewhere. All right, so to change a raw number into a z-score, you take your raw data value, you subtract it from the mean, and then you divide it by the standard deviation. Our raw data value that they gave us, they want to know about the number 501. And then the mean, they said, was 435, and the standard deviation was 60. Do all that, and you get a z-score of 1.1 for this problem. So they want to know how they want it to last longer than that, so more than 501, so that makes the lower bound 501, or the z-score of 1.1. And we're going to go to infinity. So the lower bound's 1.1, going all the way to the right is infinity, 10 to the 99th. Then you put the mean in, which, because we normalized it and made it into a z-score, the mean is 0, and the standard deviation is 1. Put in your calculator, and it says 0.13566, or 13.57%. Again, normal CDF. So second, when vars, go down to choice 2. And our lower number was 1.1. Our upper number was infinity. And it's still standardized. And so you get that number of 0.13566, or 13.57%. All right, if you have any questions, send me an email or a text and we'll work on it some more. Thank you.